In this video I'm going to solve some quadratic equations by factorising them. There's another video purely on the factorising part if you want some more practice of that. But here it's slightly different. So factorising just means taking an expression like this without the equal 0 and rewriting it as, let's do that here. So I need two numbers that add together to give 5 and times together to give 6. So that's 2 and 3. So this is x plus 2 times x plus 3. So this is true, and in fact I could make an even stronger statement here that not this equals here, but with 3 equals, it's identically equal to it. It's true for all values. Okay, so that means any value of x I put in the left hand side, I'd get the same thing if I put it in the right hand side, like 1. You know, 1 squared is 1, plus 5 times 1 plus 6, that's 12, whereas 1 plus 2 is 3, times 1 plus 4, that's 12. So that works, and it'll work for any number. Whereas if the question is to solve this, I want to find the value that makes this equation 0. So I can use that factorisation, x plus 2 times x plus 3, to replace the left hand side, because any value of x I put in here I'll get the same thing as when I put it in here. And now I want to say, okay, well, when does this left hand side equal 0? Now I've got two numbers here essentially multiplied together. You know, I'm thinking of x plus 2 as one number and x plus 3 as another number. So if I want to have two numbers multiplied together and the output is 0, one of them has to be 0. It could be like 0 times 7 or minus 3 times 0. But if they were both non-zero, I wouldn't get 0. So either we must have that x plus 2 is 0 or x plus 3 is 0. Okay. I could say that this line implies that one or the other of these two is true. So we've either got x plus 2 is 0 or x plus 3 is 0, so that means that either x is minus 2 or x is minus 3. Okay? And these are the solutions to this original equation. If we try putting them back in, minus 2, let's put minus 2 into this equation. Okay, so minus 2 squared, first is plus 4, 5 times minus 2 is minus 10, and plus 6 is just plus 6. And yes, that's all equal to 0. Similarly, if I put in minus 3, I would get minus 3 squared, that's 9. 5 times minus 3 is minus 15. And again, plus 6, and that's equal to 0. So we have found two solutions here. And we found, and there are no more, a quadratic equation can have at most two solutions. Or two roots, I should say. The solution is both x equals minus 2 and x equals minus 3. And individually, we describe these as roots of the equation. Here's another one. I want to solve x squared plus 2x minus 35 is 0. So firstly we factorise, and minus 5 plus 7 is plus 2, and minus 5 times 7 is minus 35. So this is x plus 7 times x minus 5. And so I need either x plus 7 to be 0 or x minus 5 to be 0, so that's either x plus 7 is 0 or x minus 5 equals 0, and then one of these two will be 0. So that means that either x is minus 7 or x equals plus 5. And that's the solution to this quadratic equation. Okay, how about this one? 2x squared plus 16x plus 32 is 0. Remember, if we're ever trying to factorise something, we start by seeing if there's a common factor, if there is one. Here, common factor of 2 everywhere, so it's 2 times x squared plus 8x plus 16 equals 0. And the nice thing about equations is I can now divide both sides by 2 and say that just x squared plus 8x plus 16 equals 0 here. So I can actually, once we've pulled out this common factor, it's like dividing left and right hand side of this whole equation by 2, so that's still valid. Now we can factorise this. I need two numbers that add together to get 8 and times together to give 16, so 4 and 4 work. So this is x plus 4 times x plus 4 equals 0, and that means that, well, one of x plus 4 or x plus 4 must be 0, but here they're both the same thing, so I just need x plus 4 to be 0, so that's x equals minus 4, and this quadratic equation has only one root. Okay, so actually quadratic equations in general could have two roots like the ones we've got before. They can have one real root, or sometimes they can also have no real root, something like x squared plus 1 is 0 here. This one doesn't have any real roots because it would be the same as x squared is minus 1, and there's no real number that squares to give minus 1. And it's worth saying as well, not all quadratic equations can be solved by factorising, even if you can solve them. I mean, it's I'm picking ones here that turn out nicely, and if you can factorise them, that's great. But if they don't, there are other methods to use as well. Okay, here's one that's presented in a slightly different form. X squared minus 3x is 9x minus 27, and we can't immediately try and factorise this because we've got the equals here in between the terms. So for this method to work, it all hinges on the fact that we're saying something about two numbers multiplying together to give 0. So we must make one side equal to 0 before we start here. So if I move everything to the left hand side, I get x squared minus 3x minus 9x and then plus 27 equals 0. So that's x squared minus 12x plus 27 equals 0. And now it's back in the form that we had it before. We can see if we could try and factorise it. And you can have a go, but it does factorise as x minus 9 times x minus 3 equals 0. So here we get either x minus 9 is 0 or x minus 3 is 0. So that means that either x is plus 9 or x is plus 3. Once you get it to this stage, really the answer is just whatever's in the bracket here with x, but change its sign. Minus 9 becomes 9, minus 3 becomes plus 3. Here's another one. X squared minus 4 is 0. Now you could treat this as sort of x squared plus 0x minus 4 equals 0, or recognise this as the difference of two squares if you've done it, and see that actually here now minus 2 and 2 work, because minus 2 plus 2 is 0, and minus 2 times 2 is minus 4. So this is x plus 2 times x minus 2 is 0, and so that gives us x equals minus 2 or plus 2 as the solutions. But really, that's slight overkill for this sort of thing, so do keep an eye on what you're doing, think about what's going on. X squared minus 4 is 0 is much simpler than that. We can just rearrange that to x squared is 4, so that means that x is 2 or minus 2 without as much thought. But it's nice to know that these sorts of examples are all fits together. But for this one I would just go straight to the answer here. Okay, one last example here. Minus 10 minus 5x squared is 15x. So you might say, well, it's easier to move things over here, but to make it all equal to 0, but actually because I've got this minus 5x squared, we usually prefer to have a plus x squared term in what we're looking at. So let's move everything to the right hand side, and that gives us 5x squared plus 15x plus 10. And this is a slightly harder one because we haven't just got 1x squared, but notice on the right hand side everything has a factor of 5, so I can divide 3 by 5 and get 0 equals x squared plus 3x plus 2. And then this one factorises, well, 2 plus 1 is 3, 2 times 1 is 2, so this is x plus 2 times x plus 1, so x equals minus 1 or minus 2. And you could check that they both work in here. Minus 10 minus, in fact that might be a good exercise, because especially if you're not with lots of negative numbers here. But minus 10, and if I substitute in minus 1, we get minus 5 times minus 1 squared, so that's minus 5 times plus 1, so that's just minus 5, so that gives us minus 15, and then 15 times minus 1 is minus 15, so that one definitely works. And minus 2 as well, minus 10, now this is minus 5 times then minus 2 squared, so minus 2 squared is 4, so this is 4 times 5, so this is actually minus 10 minus 20, so that's all equal to minus 30, and on the other side 15 times minus 2, yes, that's also minus 30, so that's worked. Good thing with algebra, you can, if you're solving equations, you can always check your answers by substituting back into the original equation to make sure you've got them right, which is a very good habit that excellent students will get into. Not to say you should always check every little detail, but especially in something a little bit more complicated, or if it's going to be something you're going to be using later on, much better to do a quick check rather than wasting a lot of time realizing you've done something wrong and having to sort it out later on. So that's it. Factorising quadratics we did in a previous video, and now we've used those factorisations to solve some quadratic equations.